Hello, good morning, good afternoon, whenever you're watching this. We are getting started with Unit 4, and this will be what takes us through the end of the semester. So I know it seems like a long time there, but it's really not because we have Thanksgiving break, and then we're gonna stop about mid-December early December, so we can start reviewing for the final. So this will be an average size unit, about the same length as Unit 1 and Unit 2. And we're going to get started with nomenclature. So today we're going to talk about chemical names and formulas. So your success indicators, how you know if you're successful after this lesson, is that you can explain what is a chemical formula. Hopefully you guys can already determine the difference between the two given ions, being able to name them using those prefixes and then writing their formulas. We'll also address oxidation numbers. So we'll talk about the rules for writing those oxidation numbers, which again, we have touched on already. So this shouldn't be completely brand new. So we're basically just gonna be focusing on writing the names of compounds and then writing their formulas. So today we're just going to focus on ionic compounds. So we know that ionic compounds are going to be always between a metal and a non-metal, but just generally speaking, our chemical formulas are going to give us the amount of atoms of each component in the compound. So it's important to write it in this specific way. So if you look here in the middle where it says the example, so MgBr with a subscript 2. The subscript is important, okay? So later on when we start balancing equations, which actually is not too far out, we'll be doing that in a couple weeks here, we'll be using like large numbers, regular size numbers, coefficients in the front, and then the subscripts are going to tell us something different. So it will be very important to write those subscripts as subscripts, or else it could be telling you some other kind of information. So we don't want to be mixing those up whenever we start balancing equations. So with our ionic compounds, these are always going to be made of the simplest ratio of cations to anions. Okay, so if you see this MgBr2, right, another ratio could be like 2 magnesiums and 4 bromines. So if you had a formula and it came out to be Mg2Br4, you would need to simplify that. Okay, so if you had like a 1-to-3 ratio and it was like 2 and 6, you'd have to simplify it. So ionic compounds are always going to be your simplest ratio. So this is a representation of this formula, which we already know how to do. So naming monatomic ions is where we'll start. So this is your simplest form. This is just a single atom that has gained or lost electrons. So a cation or an anion, basically. So if you have some of these common monatomic ions here on the left-hand side, so if we had, I don't know, like fluorine, so the bottom left corner here where it says -1, so you have fluorine, we know would gain an electron because it has 7 valence shell electrons. So if it's gaining an electron, it's going to have an oxidation number of -1. We already know that. So we know that that's an anion already. So there's a rule for naming that. So for naming anions, we're going to drop the ending off the element's name and then substitute IDE into the end. Okay, so instead of fluorine, we're dropping the INE and substituting IDE to make that fluoride. Cations, you don't change anything. So if it's going to be a positive ion, like it's losing its electrons, you will not change the element name. It will be exactly as it is on the periodic table. So if you look at the chart here on the left, the ones on the top are all positive, so they're all cations. These are the same element names you would find on the periodic table. The ones on the bottom are all going to be anions, and they have all dropped the endings and substituted in the IDE for that. So for binary ionic compounds, this is kind of the meat and potatoes of today's lesson. So we're talking about 2 atoms being bonded together. We already know that ionic compounds are made of a metal and a nonmetal, so we have rules for naming these as well. So it's kind of the same as your monatomic ion. So we still have like a rule for the cation and the anion. The cation is going to get its full name just like these. Okay, so if this was a positive ion, it just receives the element's name. And then the anion for these binary ones comes second, and you're changing the I into IDE. So these are pretty basic as far as naming goes. So for this one, you have NaCl, okay? That's sodium chloride. okay, not chlorine, and you're not changing anything with sodium, it's just sodium chloride. So this one, MgBr2, the 2 for ionic, the subscripts don't change anything for an ionic compound. So since this is a binary ionic compound, we're going to say it's magnesium bromide. We know that this one will be sodium sulfide and then potassium phosphide. You can see the pattern there. Okay, so the first element listed does not get changed. The second element listed will end in IDE. And you always, if you're writing these and you're not sure which element would go first, you're really just going to go in the order of the formula. But if you were starting from scratch and you were trying to arrange them yourself, you would always name the cation first. The positive one always goes first, and the anion comes second. So the metal is listed first, and the non-metal is always listed second. So for writing ionic formulas, they have their own rules here. Let's just get all this up. Okay. So writing ionic formulas, we're going to identify the oxidation number of each atom involved first. Okay, so we already know that cation will be listed first. So if you were just presented with these two atoms and I said, okay, you have lead and oxygen, what formula would they make? It's not going to just be like PbO. We have oxidation numbers involved. The amount of atoms involved depends on the way it needs to bond. And we looked at this a little bit with drawing these out when we were drawing the arrows. Do you remember when you guys had some that were like aluminum bonding with chlorine or something like that? You always had to add another atom so that you could completely transfer all of those electrons away from the central atom. So it's the same idea here. So if you have a cation that needs to give up more than one electron, you're going to have to bond it with something that either accepts 2 electrons, or you're going to add another atom to bond or to transfer out the other electron. So that's neither here nor there. That's just kind of the why behind it. Like, this is related to when we were drawing our ionic compounds. So anyway, so for the rules for writing these ionic formulas, first you figure out which one is going to be the cation, which one is the anion. So if we looked on our periodic table, you go find lead. It's in group 14. It's all the way down towards the bottom. So since it's in group 14 and it's at the bottom, it's a metal, it's going to be a +4 charge. It's going to be a +4 oxidation number, because we know, since it's a metal and it's in that column, that it's going to be giving up 4 electrons. And then we find oxygen. Oxygen's in group 16, so we know it has 6 valence electrons. It's going to need to accept 2 more valence electrons, which gives it an oxidation number of -2. So then you have to figure out what the subscripts are going to be. So to do that, we use a crisscross method, okay? So whichever superscript, whatever the oxidation number is, you're going to crisscross that down and across, and it goes with the other atom. Okay, so this +4 for the lead is going to get moved down here with the oxygen. When you move these over, the plus and minus no longer matters. It's no longer representing a charge. When you move it over, it's representing an amount of atoms. Okay, so and what that does is it balances it all out. So if we have this +4 charge, that means there's going to be 4 oxygens. And if we have this -2 charge, that means there's going to be 2 leads. So we'd write this out. So we have Pb2O4. See how they kind of switch their spots there. There's no more positive and negative on it when it becomes a subscript. And then simplify if needed. So we know that ionic compounds are going to be in their simplest ratio. So we would simplify this further by saying it's just PbO2. If there's a 1, and so we've simplified this, we know that there's kind of an unspoken 1 there, you do not write a 1. Okay, we're not ever writing a 1, even if it's a charge. So if a 1 is a charge, you just write the plus or the minus. There's no 1 associated with it, just the plus or the minus. Same goes down here. So with the transition metals, these are a little bit different. So we've talked about the reason why these transition metals can be different is because they bond with their outer 2 outermost electron shells instead of just their outer shell. These are all the elements in the D block. So these are going to form +2, +3, sometimes 1 and 4. They're always going to be cations, and the charge is going to be represented by a Roman numeral. So let's talk about that. Okay, so you're going to have to do a little bit more work to figure out the transition metals, and you're going to figure out what their charge is going to be based off of the other atom that is involved, and I'll show you what I mean by that. So same idea. You're still naming the cation first, which is going to be the metal, so that means that your transition metal will be named first. So if I had this is copper, so Cu is copper. Then you would use the reverse crisscross method to determine the charge. So we know that the cation is copper, the anion is chlorine. We know that anyway because copper is a metal and chlorine is a nonmetal. So what I mean by the reverse crisscross method, is that right here. Okay, hopefully you saw that. Watch. There we go. So this 2 that is down here with chlorine, we're going to reverse that and say that, okay, this 2 must have been put there because of the copper. Just like in the slide before this, when we took the charge of the cation and moved it down and over, we knew that we moved it down and over because that cation had a charge of 2. So here, this chlorine has a subscript of 2, so we're reversing that crisscross. So the 2 is going to go back up with the copper. We know there's an unspoken 1 here with this copper, so we're going to reverse that and put that back up with the chlorine. So what that means is that the charge on the copper is +2. It has to be +2 because this 2 is right here. So if we reverse that, we'd say that this is copper. We're going to write that charge in Roman numerals, copper 2, and then finish this out with chloride. So the same naming rules. Once you figure out what the charge is, you still just write the name of the first, you write the name of the metal, and then you change the ending of the nonmetal to IDE. Okay, so I know it's kind of a lot. Transition metals take a little bit of practice, but they really follow the same rules. It's just a matter of figuring out what their charge will be. And we write this in parentheses behind it as Roman numerals to show that this particular copper had a charge of 2. The next copper in the next compound might have a charge of 3 or 4. We don't know. So that's why we do that. That's why they have to be in parentheses there. Because if you just say copper chloride, there's really no identifying what the amount is. So that's important. So the rules for writing your ionic formulas. First, we're going to identify the oxidation number on each atom involved. So the Roman numeral tells you that. So these actually are easier for writing your ionic formulas. Okay, so for these, you don't have to look on your periodic table. You don't have to do anything. It tells you. Okay, so whatever's in Roman numerals, that's the charge. So tin we know is the metal because it's listed first and because we can look at the periodic table and see it's a metal. So tin, which is Sb, is the chemical symbol for that. We already know that has a +2 charge because it's right there. You don't have to look it up. Chlorine or chloride, we know that chloride is chlorine. It's going to be in group 17. So it has 7 valence shell electrons, which means it has a oxidation number of -1. Because it's going to gain 1 electron to satisfy its octet rule. So these would be the charges for those. And now you just go through the same way you did before and you crisscross those charges to find the subscripts, okay? So if tin has a +2 charge, this +2 would come down and over to be with chlorine. Chlorine has a -1 charge, so this 1 would come down and over. So again, we don't write the 1s, but you would write anything larger than 1. So you'd have tin, so Sb, and then Cl with a 2 to show that there's 2 chlorines to balance this 1 tin. So polyatomic ions, these you have a list for. So I'm not going to make you memorize these necessarily, but it would be helpful if you are kind of familiar with the location of these polyatomic ions on the sheet. There's a copy of this in the module for Unit 4, kind of like underneath the daily stuff. It says like extra resources. It's a sheet in there. So you can like use a little pop out thing in the corner. You can save this to your device if you want. But the polyatomic ions, again, it's kind of something we've addressed before, knowing that it's many atoms. So it's going to be more than 2 atoms bonded together. So you might have 3 or 4 different things bonded together. So it's going to be a polyatomic ion. you're going to see when you look at that chart that you'll have very similar like names for these formulas, but the endings will be different. And so how they came up with the endings is kind of this set of rules at the bottom. You do not need to memorize the rules for naming polyatomic ions. Okay, I'm not going to ask you to name them out of nowhere. You'll always have your sheet to reference, but this is where the names come from. Okay, so whenever you have a polyatomic ion, there's an ion that like occurs naturally. So it would be kind of its most common state. That one's going to get the ending of ATE. Any ion with one less oxygen than that is going to get an ending of ITE. Any ion with two less oxygens than its normal state is going to get hypo at the front and then ITE at the end. And then if you have an ion with one more oxygen than it normally would have, it's going to get a prefix of PER, so per, and then an ending of ATE. And so the reason why this kind of centers around oxygen is because polyatomic ions are normally oxyanions, meaning that they have oxygen. So if you look at that list, almost all of them have oxygen involved, or at least all of them that have like multiples of kind of the same or similar formula. And that's kind of where we get this ATE, ITE situation going on. So if we had like sulfate, if you had one less oxygen, it'd be sulfite. Two less oxygens would be hyposulfite. If you had one more oxygen than normal, it would be per sulfate. Okay, so you kind of have this rearranging there. So this is a list of polyatomic ions. These, again, like they're called ions because the entire formula gets a charge, right? So if when we start bonding these, naming them, these kind of have a little bit of a different rule. So when you start naming these, if you notice, like let's look at nitrate. So the first one in the middle. So NO3 with a -1. That entire formula has a charge of -1. So you can imagine that like the NO3 is in brackets, and that -1 applies to everything inside of it. So that's how all of these are. So when you have one of these and you're bonding it, you're going to be using that ion charge and applying it. It's going to go for like the entire ion. So for naming these compounds with polyatomic ions, and I promise we're almost done, there's some rules to that. So same thing here. We're still talking about an ionic bond. And so whenever we have these, we're going to name the cation first. Okay, so whichever one's metal, so your positive ion goes first. You're going to use your subscript on the cation to determine the charge of the polyatomic ion. Okay, so I know that sounds a little strange. And then we'll name the polyatomic ion second. So when we have this, we have NaMnO. So we have sodium, manganese, and oxygen. We're going to have 3 atoms involved. So we already know there's more than 2 things bonding. We know that there's a polyatomic ion in here. So you're going to have to differentiate these. You know that sodium's probably by itself, like sodium and Mn like wouldn't go together, but Mn and O would go together because this is a metal and a non-metal. So when we start looking at the oxidation numbers, we're going to look at these and say, okay, we know that there's an unspoken 1 that would go here with sodium. So we know that its charge, there's no subscript here, so this must be a 1 here. This means that when you reverse crisscross it, so like we did before, if we had a 1 here, this 1 charge would come up here. That means that the charge on this polyatomic ion has to be -1. So if you look this up on your chart, you would find MnO4 with a -1 charge. So to name this, you just name the cation first. So we know that this metal in the front is going to be our cation, that's sodium. And then permanganate is the MnO4. Okay, so just to name these, they're actually pretty simple to name because you're just listing the cation and then listing the polyatomic ion name. So if we go back a slide, these are the names for them. So if you see like CN on something, that's cyanide. You don't have to figure out what its name is or any of that. You just need to write it down. So writing the formulas with polyatomic ions, this is where you're going to have to do a little bit of investigating to determine what the charge would have been. So same idea here. We have calcium nitrate. So we're going to figure out like what these are. So if we look on the periodic table, we know that calcium is in group 2. It's going to have a +2 charge because it's going to get rid of 2 electrons. Nitrate, we're looking on our periodic table, or not periodic table, sorry, our polyatomic ion list. Find nitrate, you see that it's NO3, and it tells you it has a -1 charge. So you're going to crisscross the charges to determine the subscripts. What gets a little tricky with these is that your polyatomic ions are going to be by themselves, okay? So these are separate from the subscripts already present. So here, if we look at this nitrate, we see that it has a subscript of 3 already. Yeah, it's already there. We're not changing that. That stays, this was like a little unit that stays together, okay? So any polyatomic ion that you list is its own little unit. It does not get changed. So to differentiate that down here, whenever you crisscross these charges, right, the -1 would come over here with the calcium, which means we don't have to write anything for that. But this 2 is going to come over here and be on the outside, over here where this next to this 3 is. We do not want it to look like it says O32, okay? That would be drastically different than the formula that you're actually writing. So what you're going to do is you're going to put that entire polyatomic ion in parentheses. Okay, so Ca, there's no charge here, so there's no charge with this, so there'd be no subscript there. Parentheses, NO3, close your parentheses, and then whatever charge you need to address over here is going to go on the outside. Okay, so and then you can simplify if you need to. So if we had a case where this was like a 2 and this was a 4, you could further simplify that just like you did before. Let's see. Okay, so that's the end of these. So I would encourage you to get on Canvas. Let me see. Let me find this. Let me turn this on. Record this tab. Okay, so if we get in here and look at day 1. Okay. So when you get in here, we have a couple things going on. We're going to do the polyatomic mix and match game, and then the ionic compound formula practice. So what you guys have is just a bunch of practice on writing these out. So for your polyatomic ion mix and match game, let me open this up. Every time I switch pages, it stops and records on the other page. Okay, so I should be on this tab now. Okay, so I'm going to do a couple of these with you just to kind of get you started. So in class, what we're doing is they have cards, and they're randomly drawing cards. So they might get the cation of aluminum, the anion of chlorine. So I just gave you the pairs already to kind of make that more simple. So here you're going to be writing the formula and then its name. So it's full name. So the formula for this, if you look, let's zoom this in a little bit. So the formula, we're going to look at the cation and the anion. They're already in the right order. You just have to crisscross their charges. Okay, so aluminum is a +3 charge. That means there's going to be 3 as a subscript with the chlorine. The 1, and we know that we're not going to write 1. So for the formula, you'd have Al and then Cl with a subscript of 3. Okay, so then for the name, you're going to name the cation, just gets its regular name, and then you find the name of the anion, change the ending to IDE. Okay, so that's pretty straightforward. Let me do a different one. You guys don't have any other examples on here like that. Let me do a different one with, let's see, we can do barium. I'll just give you one of your extra credit ones. Barium, and then that one is a -2. That's it. Okay, let's change this. Okay, so I'm going to change this one so we have a switch here to write. Let's do lithium. Okay, so for this, I'm going to go through one of these extra credit ones just to show you what it would look like as a polyatomic ion. Okay, so if we have lithium is a +1, and then we have sulfate. So this is pulled off the polyatomic ion list. Sulfate is SO4 with a -2 charge. So here, we know that this +1 is going to come down here on the outside of the sulfate. The -2 is going to come down here over here with the Li. So we'd have Li for lithium, and we would put in the subscript. And then because there's going to be a 1 on the outside and we don't write 1s, you do not have to put this in parentheses. But if it was a different number, so let's say you're going to put a 3 on the outside of this, you would need to. So if I'm doing this, sorry, we do not have to have so 4, and then that's it. Okay, so for the name, you would again just list the metal and then the polyatomic ion name. Okay, so if I had a different one, let's just say I have aluminum, okay? And then we have, oops, a superscript. Not sure what I just did, but okay. So if I have aluminum, and then we're just going to copy and paste that. All right, same thing here. This +3 charge from the aluminum is going to come down and across, and it will be with the sulfate. The -2 charge is going to come over. The 2 is going to come over with the aluminum. So we have aluminum. Sorry, I'm not sure why this formatting is looking weird here, but I did something. So aluminum is going to get the 2. We're going to have the subscript of 2. And now we know that that 3 from the aluminum as the cation is going to have to come over. So we're going to have to put sulfate in brackets, SO4, sorry, parentheses. So the entire sulfate, SO4, gets in parentheses. And then that subscript comes down on the outside. Okay, so hopefully it's starting to come together a little bit. So for as far as the naming goes, kind of the same idea. So aluminum, we don't change, and then sulfate, we still don't change. Okay, so we're not doing anything to change those. Another example could be one with a transition metal. Okay, so if I had, I don't know, let's do chromium, and I give it a subscript of, let's make it chromium 4. And then let's bond that with, let's do oxygen, okay? So that's going to be a -2, okay? So chromium is a transition metal. So if you look at it on the periodic table, it's in group 6, so we know that's a transition metal. I've provided you with the charge, so we don't have to do any digging to find that. The oxygen, we know, is going to be -2 because it's in group 16. It has 6 valence electrons. It needs 2 more. It's going to be gaining 2 electrons. So to crisscross these, we know the 2 from the oxygen will go with the chromium. So we're going to put that 2 there. And then for the oxygen, the 4 is going to come over from the chromium. Now, if we look at this is not the simplest version, okay? So we would then have to change this into chromium with a 2 after the oxygen. Okay, so this would be how it would be written right here, just using your crisscross method. But we know that with ionic bonds, we have to simplify them. So we would further simplify this. So the naming is still the same, except we're just adding in that Roman numeral to represent the charge on the transition metal. So chromium, it's written first, parentheses, 4. Because this was the original charge was +4. So we're going to put that in parentheses, chromium 4 oxide. Okay, so instead of oxygen, we're taking out that ending and changing it into IDE. So this is just a few examples. I'm not going to give you extra credit for these if you use exactly the same examples. So use something different for your examples if you want to get extra credit points for these. But I just wanted to show you kind of where we were at here. So these are just some other examples of that. So you have pretty simple ones for the mix and match game, but you do have some of these more complicated ones on the assignment. So please let me know if you have any questions. This is just a bunch of rules for naming, and that's really all it is. It's just a matter of practicing these. You're going to have to practice them to memorize these rules. So if it comes down to it and you're really just struggling, I can provide you with like just like a list of them to practice, or maybe I can make a Quizlet or something so you guys can practice them. So let me know if you're struggling with this. If you need the Zoom or something, we can just set up a Zoom meeting and just like go through them or address any questions you have. So let me know if you need any help with these. We're just focusing on the ionic bonds today, so we'll address the next class. Please let me know if you have any questions. I will talk to you guys next time.